Okay, so I'm Xiaoling Li, recently graduated PhD student, not a student anymore, from City and Regional Planning. And today I want to present part of my dissertation research is site selection of urban parks using GIS and programming languages. So about site selections, we're all familiar with this phrase, and site selection is all about spatial locations. And it answers the question of where. Where shall we locate something? For example, for the planners or city policymakers, they have to decide, well, where shall we locate public facilities like schools, fire stations, or hospitals, or parks in order to provide better service for public. And for business people, they have to think about where to open a new store or where to open some factory in order to maximize their benefit or minimize their cost. And for us, the site selection is also related to our daily life, because if we want to buy a new house, we have to decide, okay, which location is the best choice among multiple options. And ArcGIS do provide some site selection tools for us to answer these questions. And we can find these tools in the Network Analyst extension using the location allocation tools. And these tools help us to answer the questions like, say, if the city wants to build a limited number of facilities, how do we maximize the service coverage? Or on the other side, answer the question of, if we want the full coverage of the service, then what is the minimum number of the facilities that need to be built, and how to locate those facilities? However, if we're working on the real world cases and deal with more complicated criteria, these ArcGIS tools, built-in tools, cannot answer such questions. For example, if a city wants to provide some park service and build some potential parks, but they have the limitation of budget. So it is not realistic to build parks everywhere. They have to decide, well, where to build the parks. And because the budget, the planners have to say, well, how about in the short-term goal, we're going to achieve the goal that 90% of the public can reach a certain amount of green space within, say, quarter mile. And for the rest 10% of people, even though they are a bit further from the park, but they can still achieve, access the green spaces or parks in like half mile or 600 meters. In order to answer such complicated questions, we have to build our own customized optimization models in programming language. And I use Python, taking advantage of ArcPy site package in Python provided by ArcGIS. So the simple steps are, I prepare the data in ArcGIS using our toolbox or ArcPy. So I first identify the demand points as residential sites, and then the supply for as the parks as the supply. These parks not only include the existing parks, but also some potential parks taken from the say current city plans. And then I import this data to the site selection models I built in Python, and a set of objectives and constraints have been set up. Like, for example, we want certain amount of coverage, or we have limited budget, or we want, any of the green space, we don't want those green spaces to be too crowded or too occupied. We want certain people to enjoy a certain amount of green spaces. After we set these objectives and constraints, we run the model and get the model result. And we write these model results back to the shape files so we can present and analyze the model result in ArcGIS. And there are some interesting findings from the model results. I classify these green spaces into different categories according to the model result and also the current status of the candidate sites. And interestingly, we find that, for example, the red ones are the green spaces that are not current parks yet, but they are in urgent need. So the government have to spend more money on this part of, park construction recently. And also the other interesting findings are those purple ones. Purple green spaces they are in some recent city plans to be built. Like, that means they're planned to be built as urban parks in the future. But according to the model result, those purple ones are actually not necessary, like redundant. So in conclusion, a combination of ArcGIS and programming language using optimization models can really facilitate people to make smart choice. Okay.